Hello everybody and welcome. Thank you so much for joining me here today. In today's video, we're going to be talking about standard deviation, and we're going to be tackling some problems that you could expect to see on the GMAT or the GRE or other similar exams. So with that, let's dive right into it. First of all, what is standard deviation? If we're talking about standard deviation, we need to understand what it is. So let's just think of the words standard deviation. What are some synonyms for the word standard? You might come up with words such as typical or common or expected, maybe normal. And what about deviation? Well, the word that comes to my mind whenever I think of deviation is the word difference. So putting it together, standard deviation is the expected difference from the mean or the average. The way you find standard deviation, well, first of all, standard deviation is denoted by this symbol here. And the way you find standard deviation is by taking the square root of the variance of your list of data. And if you're wondering how you find the variance, so variance is found by finding the sum of some point of your data subtracted from the average point of your data, the mean. You square that and then you divide by the number of terms. So this is how you find the variance, and then you take the square root of that to find the standard deviation. If you're looking at this and you think it seems kind of complicated, you're not wrong. It's way more involved than finding something like the median or the mode of your data set. However, you're in luck, as in for the questions for standard deviation on the GMAT or GRE, 99% of the time, they're not asking you to calculate the standard deviation. What they're going to do instead is they're going to ask you how the standard deviation is influenced whenever you add an additional number to your data set, or it might give you a bunch of different sets of numbers and ask you to rank the standard deviation from least to greatest. So let's talk a little bit about that. So standard deviation is in essence the variance of your numbers against the mean. So if your numbers are really close together, you're going to have a small standard deviation. And actually, if we have a set of numbers that are all the same, like let's say 5, 5, and 5, then our standard deviation here is going to equal 0 because all the numbers are equal. So the distance from the average value, here in the list, our average value is of course 5, and the distance from 5, the average distance from our mean, is 0. So our standard deviation, whenever all the numbers in your list are identical, is 0. Another property for standard deviation is that our standard deviation is always going to be greater than or equal to 0. It's always going to be a positive value. Okay? Again, so let's talk about ranking standard deviations in order from least to greatest. So of course our least standard deviation would be whenever our list of numbers is all the same, such like 5, 5, and 5. A standard deviation that is small but larger than 0 would be something like 1, 2, 3, where all the numbers are really clustered together, but they're not identical, so there is some spread amongst the numbers. And a set of values that would have a large standard deviation would be something like 1, 100, 1000. Here, these three numbers are really spread out, so you're going to have a large standard of deviation. Okay, let's also quickly talk about how your standard deviation would be affected if we introduced a new value to our list. So let's say we have a list of values. Let's make our list 2, 2, 2, 4, 4, 4. Okay, so our standard deviation for this list of numbers is going to be pretty much 1. Might be a little bit different than 1, but it's going to be practically 1. And we know that because our average of this list of numbers is 3. And then each of these values, 2 and 4, are only 1 unit away from 3. So our standard deviation is going to be roughly 1. So what is an additional value we could add such that our standard deviation would increase? If we want our standard deviation to be larger than 1, what value should we add? Well, we should add a value that is more than 1 standard deviation away from our mean. Since our mean is 3 and our standard deviation is 1, we could put in a number like 5 that is 2 units away from our mean, and that would increase our standard deviation. We could also put in a value like 1, which is 2 units below our mean, and this would also increase our standard deviation, as it would increase the spread of our values from our average, from our mean. If we put in the value of 3, if we put in a value that is our mean, how would this affect our standard deviation? Well, this would actually lower our standard deviation, and if you want to have the lowest standard deviation possible, then you're going to add in as many values equal to the mean as are allowed. Okay, the more 3s we add in, the closer our standard deviation will approach 0, as 3 is our mean, so adding in your mean to your data set will just pull in the deviation from your mean to closer and closer to 0. I hope that makes sense. I know it's a lot of words said. So that is what adding a number will do to your standard deviation. Let's also quickly talk about changing your set of values. Sometimes your set of values, again, let's make up a list. It can be, 2, 4, and 6. Let's say 2, 4, and 6 have some standard deviation. Now, let me ask you, does the list 4, 6, and 8, is this standard deviation the same or different as our initial list? Well, our standard deviation is actually going to be the exact same. It's going to have the same standard deviation. While our mean did change, standard deviation is all about the spread of your values from your mean. Okay? In our first list, our mean is 4, and 2 is 2 away from 4, 4 is 0 away from 4, and 6 is 2 away from 4. In our new list, our mean or our average is 6, and our spread is the exact same. 4 is 2 away from 6, 6 is 0 away from 6, and 8 is 2 away from 6. So since the spread of the numbers is identical, your standard deviation will be the same. With that, we have a property such that if you add or subtract any value, any number to your list, your standard deviation will be the same. So if we have a new list that's 2 plus some n, 4 plus some n, and 6 plus some n, then this standard deviation will be the exact same as our original list. And that's again because the spread of our values is not affected. So what would change our standard deviation? So if plus and minus a value across our set does not change our standard deviation, would multiplying a value? And think about it for a moment. Would multiplying a value across our set change our standard deviation? Okay. And the answer is yes. If we multiply by some value of n, what would happen? Well, let's say n is equal to 3. So if we multiply 3 across this list, what do we have? 2 times 3 is 6. 4 times 3 is 12. 6 times 3 is 18. So notice that our numbers are now spread out. We went from a gap of 2 to a gap of 6. 0 times 3 is still 0, but 2 times 3 is 6. So our spread amongst our mean went from a 202 to a 606. So our numbers are more spread out. And so our standard deviation did increase. And actually, it increased by the same scale factor in which we multiplied our set by. So the standard deviation of this green set of numbers is equal to 3 times our original standard deviation of our yellow set of numbers. So if you scale a data set by some factor, your standard deviation is influenced by that same factor. Okay? The only thing else I would say about that is, remember, standard deviation is always positive. So if our n value was like some -3, and this was -6, -12, and -18, our standard deviation would still be 3 times our original standard deviation of our yellow data set. And so you can think of it as just taking the absolute value of your scale factor. So I think that covers everything for how standard deviation is influenced. So now let's tackle some problems that you could expect to see on the GMAT or GRE. So let's look at these problems. Set S has a mean of 10 and a standard deviation of 1.5. We are going to add 2 additional numbers to set S. Which pair of numbers would decrease the standard deviation the most? Okay, we want to lower our standard deviation. So we've already talked about this. To lower your standard deviation, you want to add numbers that are equal to your mean, to your average value of your data set. And again, this is all because standard deviation is all about the spread of your values from your mean, from your average, okay? And so if you have a bunch of values that are equal to your mean, that implies that your data set has a smaller range, a smaller deviation from what is expected. So if we're told that the mean is 10 and we're adding 2 additional numbers to our set, the 2 numbers that would be best fit to lower our standard deviation would be 10 and 10. However, looking to our answer choices, we don't have 10 and 10, so the next best thing is 9 and 11, as they are closest to 10 and 10. So this answer is answer choice D. Next question, consider the following sets, L, M, and N, and rank these sets from the least standard deviation to the greatest standard deviation. Again, we've already talked about to have the lowest standard deviation, to have a standard deviation of 0, all the values in your set need to be identical. And we see that N has a standard deviation of 0 as all the values in set N are identical. So we can already eliminate answer choices A, B, and C, and now we need to choose between D and E. So let's look at set L and set M. So set L has 3, 4, 5, 6, and 7. So let's look at the spread of our values from the mean. The mean of set L is 5. Okay. 3 is 2 away from 5. 4 is 1 away. 5 is 0 away, 0 away, 1 away, and 2 away. So these numbers are pretty close together. They're lumped together, absolutely. And let's look at set M. M is made up of 3 2s and 3 8s. So the mean is again 5, but the spread is uniform. The spread of these numbers are all 3 away. However, even though we have a uniform spread, we're going to have a higher standard deviation because our values are typically farther away from the mean than in set L. So set L is going to have a lower standard deviation when compared to M. So our answer is going to be, again, answer choice D. In order from least to greatest, for standard deviation, we have set L, set N, then set L, then set M. Next question. Which of the following has the same standard deviation as S, R, and T? So let's look at option 1. Option 1 is just subtracting 2 from each of our values. Our values are reordered, but that's okay. A data set of 2, 3, and 4 is going to have the same standard deviation as a data set of 3, 2, and 4. Okay, the ordering of your data does not affect the standard deviation, as standard deviation is only focused on the average distance from your mean. Okay, so the ordering is not so important for your data. So with that, we can see that R, S, and T are all just being subtracted by 2. And we've talked about this. If we subtracted 2 from each of our values, we'd have 0, 1, and 2. And while our mean did change, our mean changed from 3 to 1, the spread from our mean remained constant. Therefore, option 1 would have the same standard deviation as our original set. Okay? What about option 2? In option 2, we have 0, S minus T, and S minus R. Okay, so this is a little bit different. How could we get 0, S minus T, and S minus R? Our original set is S, R, and T. And so I'm seeing, hey, if we, if we subtracted S from all of these, and had a negative, we could have S minus S, S minus R, and S minus T. And all we did here was what? We multiplied our set. We multiplied our original set by a negative 1, and we are left with a negative S, a negative R, and a negative T. And then we just added in an S. We added in some value of S. And so S, S, and S. And then, of course, S minus S is 0. And so we have the set 2 we're asked about of 0, S minus T, and S minus R. So would this set have the same standard deviation? Again, think of the operation we did. We multiplied by a negative 1, and then we added some value uniformly across our set. So we have talked about how multiplying will influence your standard deviation, but if you multiply by 1 or negative 1, your standard deviation is not going to change because the spread of your values from the mean will remain constant. Second, we've already talked about how adding or subtracting a value uniformly across your set won't change the mean. So option 2 of 0, S minus T, and S minus R will not change our standard deviation. It will also have the same standard deviation. Okay. Lastly, we're on to option 3. Option 3 is telling us that we have the absolute value of S, R, and T. And so for option 3, let's create a set. Let's say we have, negative 2. Let's have negative 2, 0, and 3. Okay, if we have negative 2, 0, and 3, and then we took the absolute value, our new set would be 2, 0, and 3. Okay, and notice how now our numbers have some different spread. We have a different spread, and this might be best illustrated on a number line. On a number line, we have 0, negative 2, and 3. And these numbers are spread out, not uniformly, but they have some spread. And then our new spread would be 0, 2, and 3. Notice with these two values now more closely lumped together, we're going to have a different standard deviation. And so 3 will not keep our same standard deviation. And so our answer is going to be answer choice D. Only options 1 and 2 will keep the same standard deviation. Next question. All right, so this question is something I've already solved on my 100 hardest GMAT problems video. It's in the arithmetic section for problem solving. That is part 5 of the video. I'll have it linked down in the description below. Definitely recommend you check that video out. But let us look at this problem again right now. It says, for each student in a certain class, a teacher adjusted the student's test score using the formula y equals 0.8x plus 20, where x is the student's original test score and y is the student's adjusted test score. If the standard deviation of the original test scores of the students in the class was 20, what was the standard deviation of the adjusted test scores? So this question's asking us, how is our standard deviation influenced or changed whenever all of our values in our data set are put through this function of y equals 0.8x plus 20? Well, we already know that adding a value uniformly across our data set does not influence our standard deviation. So we can more or less ignore this plus 20. However, we should know that multiplying by some scale factor does influence our standard deviation. And so if our original standard deviation is 20, our new standard deviation is going to be 20 times 0.8 times our scale factor. And 80% of 20 is 16, so this answer is choice B. What is the standard deviation of Q, a set of consecutive integers? So we have some set of consecutive integers. So option 1 tells us that Q has 21 members. All right, this is fantastic. Because we know that we have a set of consecutive integers, so we could have something like, 1, 2, 3, all the way up to 21. In here, we could find the mean. We know the spread of all of our values, and so we would be able to calculate the standard deviation. Again, for these data sufficiency problems, you don't actually have to solve the problem. You just have to figure out if you have enough information so that you're able to solve the problem. And here we would have enough information, as it's not so important where we start, right? We could start at 0 and go to 20. We could start at 20 and go all the way up to 41. It doesn't so much matter because all 3 of these sets would have the same standard deviation. Okay, because all that really matters is how many members are in our set and the spread amongst all of our numbers. So statement 1 is sufficient to answer this question. What about statement 2? It says the median value of set Q is 20. Okay, well, with this said, we know the middle value is 20. If we had a set that was just this value of just 20, our standard deviation would be 0. However, if we began to add members to our set, keeping the median value of 20, well, now we have a different standard deviation. And if we continued to add members to our set, we would again have a different standard deviation. So statement 2 is not sufficient. So our answer here is going to be A. Statement 1 alone is sufficient to answer the question. Lifetime of all the batteries produced by certain companies have a distribution which is symmetric about mean M. If the distribution has a standard deviation of D, what percentage of the distribution is greater than M plus D? All right, so let's draw a little graph here. So a standard this says our standard deviation is symmetric about our mean, okay? And so how could we draw this? Well, this is going to be a bell curve graph where we have, some bell curve. It just looks like this. This is a normal distribution. Pay attention to this problem because you sometimes see these problems with standard deviation. And the very center of our bell curve represents our mean. Okay? And then we're told that, or what are we asked for? We're asked for what percentage of distribution is greater than m plus d, where d is the deviation from our mean. And so if we draw in some line, this line would represent m plus d, and a line over here would represent m minus d. So this line is m plus d, our mean plus our deviation, and this line over here is our mean minus our deviation. And we're told that our distribution is symmetric about our mean. Okay, and this is really important. This tells me that m minus d, that this section of m minus d would be equivalent to this section of m plus d, as again, everything is symmetric about our mean. So in statement 1, we're told that 68% of the distribution in the interval from m minus d to m plus d inclusive. Okay, so we're told that all of this space from m minus d to m plus d inclusive represents 68%. Okay, so are we able to determine what percentage of our distribution is greater than m plus d from this statement? Well, absolutely, because if we're solving for m plus d, and we know m plus d and m minus d to be symmetric, then we know that the tails of our distribution must add up to the remaining 32%. And since our tails are symmetric, that means each tail represents a uniform 16%. And so therefore, our percentage of distribution greater than m plus d would be 16%. So statement 1 is sufficient. What about statement 2? Statement 2 tells us 16% of the distribution is less than m minus d. Well, less than m minus d being 16% is perfect information for us because we know that we are symmetric about our mean. Therefore, the percentage greater than m plus d would also be 16%. So both statements 1 and 2 are sufficient for us to answer this question. So our answer is going to be answer choice D. Fantastic. Okay, last problem. What do we have? We have a scientist recorded the number of eggs in each of the 10 birds' nest. What was the standard deviation of the number of eggs in the 10 nest? Okay. What does statement 1 says? It says the average number of eggs for the 10 nest was 4. So from statement 1, we could have a list like 4, 4, and 4. Of course, we would have 10 values, but just to save some time. Or we could have values such like 3, 4, and 5. This would be an average of 4. So we can already see that we can create two sets with different standard deviations. So statement 1 is not sufficient. What about statement 2? Statement 2 says each of the 10 nests contain the same number of eggs. Well, this one's fantastic because if we have 10 nests that contain the same amount of eggs, we could have, 2 eggs, 2 eggs, and 2 eggs. We could have 3 eggs, 3 eggs, and 3 eggs. We could have 4, 4, and 4. It doesn't so much matter the number of eggs, since all of the numbers are uniform, our standard deviation will be 0. Therefore, statement 2 is sufficient to answer our question of what is our standard deviation. So our answer will be answer choice B. So there you had it. There is hopefully a quick video for answering these standard deviation questions for the GMAT and the GRE. I hope you see now how standard deviation is influenced whenever you add in a value to your set. So if you found this video helpful, please give this video a like, and if you're new, subscribe to the channel. I'll see you in the next video.